Okay, so this video is going to go over this practice written question called prime list. Now, it is the beginning part of the year, and so some of you might look at this and go, there's no way I could write this out right now, but this is kind of what would be expected towards the end of the year. And so it's not that difficult, but writing it out by hand is definitely a challenge because you really kind of have to think through how this would work. I think that after this unit, most of you could sit at the computer and figure out how to do this on your own. But usually you kind of have to be able to test it and work through the kinks that you may have. So let's go through this and think through how we would solve this. And like always, I will post this, and I believe the answer to this is on here. Yep. So you can just look at the answer, but I'm gonna code this out, and we'll kind of think through where pitfalls would be and how we would do this. But it would be a good idea for you to print this out and try writing it on your own and see how you do. So a positive integer is a prime if it is divisible by 1 and itself only. 0 and 1 are not considered prime numbers. Write a program called prime list that prompts the user for an upper bound, a positive integer, and lists all the primes less than or equal to it. For example, if the user enters 20 for the upper bound value, the prime numbers that will display will include 2, 3, 5, 7, 11, 13, 17, and 19. Create a method called setPrimeNumber and display the prime number in this method. So I set up a main prime list and a prime list program, and I'm gonna just to clean this up, I'm gonna get rid of all these comments. So you need the scanner. So import java.util.scanner. You need the scanner class because you got to ask the user to enter in information. So I'll say scanner, my scanner equals new scanner system.in. And this first part, I'm just going to write this real quick just because we got our class called prime list, and I'm just going to write this real quick, and then we'll go through some of the logic and think through how to do this. So prime list, my prime list equals new prime list. So ask the user system.out.println, please enter a number to view all the prime numbers to your number, or all the prime numbers, yeah, I guess to your number. I guess I don't know. That can be, you could change that up if you want. I'm not really sure how you say that any better. Alright, so that gives us that, and then we'll just say, something simple like int number equals my scanner.next int, and whoops, I spelt my scanner wrong up here. So alright, so that's good. So then we would say my prime list dot set prime list. We'll pass in the number. Alright, so let's kind of get back to this and think about how we would do this. So let's say we enter 13, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Well, we already said that from this, our prime numbers would be, 1 would be excluded, so we would have 2, 3, 5, 7, 11, and 13. So 2, 3, 5, 7, 11, and 13 would be our prime numbers. And we know this because there's nothing that can be divided into here to give you only 1 and 2, or sorry, 1 in itself. So 1 and 2 work, 1 and 3, 1 and 5, 1 and 7, 1 and 11, 1 and 13. Those are our prime numbers. So we have to figure out an equation. So we have to figure out an algorithm to get rid of this one, to get rid of 1, and I don't know if there's a, let me see if I can, if there's like an X. Either, let's do this maybe. We want to find an algorithm to get rid of that 1. And this might be too hard. Shape fill, no fill. Okay, cool. We can copy that and just paste. So we need to find an algorithm that will work to get rid of all of these values right here. Okay, paste. 8. Paste. 8. 9, because there 3 is a multiple of 9. 10. Paste. And 12 right here. So we want to figure out how to get rid of all these numbers in our prime list, but then keep the ones right here, which are our prime numbers. So first of all, we're going to have to use a loop that loops through and checks every single one of these numbers, all right? So this is going to be an outer loop, okay? So it will first check, well, first of all, we want to skip 1 because we know that 1 is not a prime number. So we know that our outer loop is not going to start at 1. Our outer loop will start at 2, okay? And then what we want to do is we need to just, the inner loop is going to go through each one of these, and it's going to have to take, like, let's say we get to 5. 5 will need to be divided by 2, 3, and 4 to see if any of these numbers are multiples of 5. And if they are, then it is not a prime number. For like 6, 2 is a multiple of 6. So 2 goes into 6 3 times. So, and then 3 goes into 6 2 times. So only the prime number can only be 1 in itself. So because 2 and 3 are multiples of 6, we've got to get rid of that. And sorry, I screwed that up. That is supposed to go right there. Okay. Oh no, wait. No, that's right. These are, I'm sorry, the circles are the ones we're getting rid of, okay? So 4 has a multiple of 2, so that wouldn't work with our rule. So again, the outer loop will go 1 at a time. The inner loop, once we're in, we'll have to go through every single one of these, all right? So let's do this. So we have our method called set prime list. So public void set prime list, and we're passing in int number, and then I would just say my number equals number, and I'll say int my number, and we're going to have a Boolean value that just says is prime. And that will check to see if it's prime or not, all right? So system, if it's true, it's prime. If it's false, it will not be a prime number. So system.out.println, we have our prime list that we're creating. Okay. And I would say for int I, and now remember 1 isn't a prime number, so I'm going to start at 2. And 2 will be it will start off at 2, and that will be less than or equal to my number. So in here, let's say I typed in 13. So 13 would get passed. That's my outer bound, right? So I want to check all the prime numbers between 2 and 13. So then I would say I plus plus, okay? Because we'll start at 2, and we want to check this number. And then we'll go to 3, then 4, then 5, then 6, and 7, okay? And so down here, we'll say if is prime, meaning that if is prime is true. So if true, then we system.out.println our value I. Let me think here. Yeah, I think we'll just print I plus blank. Yeah, let's do this. Okay, so inside there, we will say, let me think here for a second. Whoops, that's why, because it's not inside this loop. Sorry about that. That's why that was an error there. Something's not lined up properly. Let me look at this real quick. There we go. Okay, so that's alright, so that's better. Alright, so now we've got, so we're going to check each one of these and check to see if it's prime, okay? We will start off and just assume that all of these numbers that we're going to run through are prime, okay? So we'll say 2 is prime, 3 is prime, 4 is prime, 5 is prime, 6 is prime, 7, 8, 9, 10, 11, 12, 13. We're assuming that they're prime. Okay, so this is going to get through, this is going to go to, like, this is thinking through how to create an algorithm, again, that will cross out, basically, all the ones that we don't want, okay? But to do that, we have to assume that we check every single one, and we assume that they're all true at first. The meat of this thing is going to be figuring out the algorithm, how to turn it off and set it to false if it's not prime. But if you were able just to even get through all of this right here and think through this, you're, 70% of the way through this program and have figured out how to do almost the entire algorithm. This is the hard part here, okay? We have to have another for loop. And that's where we're going to say int x equals, and we'll start at 2, okay? We'll say that x is less than I, x plus plus, okay? Now, I started at 2. Watch this. So 2 modulus 2, well, I'm going to get to that in a second. Inside here somewhere we're going to have to say is prime is equal to false. And there's a reason why I start at 2, because my algorithm that I'm going to use would not work for 2 if we started this thing at 1. So we just assume, so x is 2 and I is 2. Since 2 is not less than 2, then this is done. And so is prime is true, so it prints 2 first. Okay? Excuse me. I've been talking so much the last few days that I need some water. Okay, so Now what we're going to do is so this is going to set us up with false. This will flip this prime to false. And if we hit this inside our if statement, then this won't print at the end. And so we know that that number is not a prime number. So inside here we'll have another, an if statement. An if statement. And that's where we're going to check I modulus x, and we're checking to see if it's equal to 0. Okay? And this is it, but we should definitely kind of talk about why this would work, okay? So, again, we know that 2 is prime, so I start at 2, I start at 2 here. Is 2 less than 2? Nope, so we skip it, and so it would print 2. And I think I want an ln, or just a print right here, so it would print 2. Maybe we do that right there. So then, we skip that. So 2 is less than 2, or 2 is less than 2 is false, so this doesn't run, it prints 2. I becomes 3, right? So x is 2. So let's kind of think through this. X is 2, and I is 3, okay? That's true. So then what we have here is 3 modulus 2. How many times does 2 go into 3? It goes in 1 time with a remainder of 1. Okay? So 3 modulus 2 is 0. That's false. So this doesn't get hit, okay? And then it comes back up, and then it goes x is 3 now. Because it was 2, we add 1 to it, it becomes 3. Is 3, so this would be now 3. Is 3 less than 3? Nope. It skips this section right here. And then this is still true right here. So it's true, so it prints 3. Okay? Next up we've got, so this is done now, and then x becomes 4. Or, sorry, I becomes 4. So x becomes 2 again. So is 2 less than 4? Yep, that's true. So then what does I become? I is 2 modulus 4. All right? So how many times does 2 go into 4? It goes in 2 with a remainder of 0. So this is 0. So that makes this, so that ensures that our value I, I'm sorry, I wrote that backwards. This was 4 modulus 2. I wrote that backwards, sorry. So 4 modulus 2 is 0. So since that's true, it is prime to false. Okay? And remember, we're inside this inner for loop. Once I'm in here, I can't switch it back to true until we start a new iteration, a new outer loop. So I don't need to check. I mean, what we could do is then we can go is 3 less than 4, and then go 3 modulus 4. That would not be 0, so it would skip it, but this already got hit, okay? And since it got hit, once this is done iterating, it would go into here and say if false, and so false is not true, so it wouldn't print this. So 4, it would skip it, okay? So then eventually we get through this, and then we add 1 to I, and I becomes 5. This gets set back to true, so then we've got 2 is less than 5. Okay, and so then what are we going to do here? We've got 2 modulus 5. Okay, wait, I got it again. I got it backwards. I got 5, and then x is 2. So how many times does 2 go into 5? It goes in 2 times with a remainder of 1. So 1 is equal to 0. That's false, so it skips that. Then it goes back up. x becomes 3. How many times does 3 go into 5? It goes in 1 with a remainder of 2. So is 2 equal to 0? That's false, so it skips it. This becomes 4. This becomes 4. So how many times does 4 go into 5? It goes in 1 with a remainder 1. Is 1 equal to 0? Nope. So then this becomes 5 is less than 5. Is 5 less than 5? Nope, it's false. So this never got changed to false, so 5 is a prime number. And so it would go through each of these over and over again. And the basics of this program are pretty easy, but figuring out this algorithm and realizing that you have to check, wherever you're at in your list, you have to then go through the beginning of the list and check every single multiple of the numbers prior to it and check to see if they are divisible by 0, or if they're divisible only by itself in 1, and if they're not, then you don't print them right here. So spend some time kind of thinking through this. You can program it. This should work. Let me just make sure I didn't, screw something up. So I'll enter my number 13. So 2, 3, 5, 7, 11, and 13. And you could even have like an extra, if it's prime and not equal to my number, then you could just print I and not the comma there. Either way, it's fine. These are your prime lists. So you could do it like that, or what you could do is you could just say print ln and not even do this right here. And you could print it like that too. Let's see here, 13. So 2, 3, 5, 7, 11, 13. So that might look better to you. So anyway, like I said, spend some time on this. This isn't easy to write out without a computer in front of you and to do some testing. So this video is done.